Hope you're having a productive day. In this video, we will be attempting some projectile motion past paper questions for CAPE Physics Unit 1, Paper 2. So let's get right into it. The question we will be attempting in this video will be taken from the 2010 Paper 2. It will be question number 4, Part B. It reads, a boy jumps off a flatbed truck that is 2.2 meters high. The initial velocity of the boy is 1.6 meters per second at an angle at 20 degrees above the horizontal. The question asks you to state the horizontal and vertical components of the initial velocity, calculate the time taken for the boy to reach the ground, and how far horizontally from the truck does the boy land. So the first thing you can do is try to familiarize yourself with the information that is given in the question, and familiarize yourself also with what the question is actually asking you to figure out. Once you've done that, then you can actually move on into solving the question. So the first thing I'm going to do is a little sketch to represent the information that we have been given in the question. So this line will represent the flatbed truck that the boy is standing on, and he moves off with an initial velocity. However, his velocity is at an angle to the horizontal, so his velocity is going to look something like this. He also lands off of the truck onto the ground. So the initial velocity for the boy was stated to be 1.6 meters per second, and the angle at which he made with the horizontal was 20 degrees. The height of the truck surface that the boy jumped from was stated to be 2.2 meters. So this is the information that we got from the question. The first part of the question asks us to state the horizontal and vertical components of the initial velocity. In order to do that, we're going to have to use some trigonometry. The vertical component of this initial velocity, if we can write it over here, this is the initial velocity, which is 1.6. And then the vertical component of this velocity is going to be this component here. So this is the angle, and this is the vertical component. We can see that the angle directly faces the vertical component, which means that this vertical component is opposite of this particular angle. This 1.6 over here represents the hypotenuse. So we end up with something where we have the opposite and the hypotenuse. We're trying to find the opposite. So when you have opposite over hypotenuse, you know that it's equal to sine of the angle. So sine of theta is equivalent to the opposite, which we can denote as uy, since it's the y component of the initial velocity, over 1.6. And the 1.6 is meters per second. So sine of 20 is equal to uy divided by 1.6 meters per second. Now, in order to get uy by itself, we have to do something to this side of the equation so that the 1.6 is removed. In order to do that, we will multiply this side by 1.6. When we multiply this side by 1.6, what happens is that there's a 1.6 in the numerator and a 1.6 in the denominator. When that happens, let me write it out for you to see. So we have a 1.6 in the numerator and a 1.6 in the denominator. The 1.6 will cancel out, and we get 1. 1 times uy is uy, because 1 times anything is itself. So 1 times uy is uy, which means we have gotten uy on this side of the equation by itself. So because we multiplied this side by 1.6 meters per second, we have to do the same to this side to maintain the equity of the equation. So now we're going to write sine 20 times 1.6 meters per second is equivalent to uy. When you plug this into your calculator, you should get uy is equivalent to 0.547 meters per second. So that's the y component of the initial velocity. The question also wants us to find the x component of the initial velocity. Now writing back the hypotenuse, the question now wants us to find this component, which is the x component, or that component right there. In order to find that, we are still given the angle, and we have the hypotenuse. Now the angle is enclosed by this x component, which means that this x component is the adjacent to the angle. And we also have the hypotenuse. So adjacent divided by hypotenuse is equivalent to cosine theta. So cos theta is equal to adjacent, which in this case is going to be ux, divided by the hypotenuse, which is 1.6 meters per second. So we're going to do the same thing. We're going to multiply cos theta by 1.6 to get ux. And when we do that, we get ux is equivalent to 1.5 meters per second. So that's the first part done with. Now we must calculate the time taken for the boy to reach the ground. In order to do that, we will have to use a kinematics equation. The kinematics equation that we will use will depend on the information that is given as well as the unknown that you are trying to find. It just so happens that when we are trying to find time and we're given displacement and velocity and acceleration, we can use a particular equation. And that equation is going to be S is equal to ut plus half at squared. But we're going to modify this equation to suit the vertical aspect of this particular situation. The reason we're using the vertical aspect of this particular problem is because even though the question did not give us an acceleration, once there is a vertical movement in projectile motion, the acceleration for that movement is going to be 9.8 meters per second squared, because that's acceleration due to gravity. Now, depending on how you set up your coordinate system, which direction you designate as positive or negative will vary. But for me, I designate up as positive and down as negative, which means that for the vertical component of this projectile motion, there is going to be a negative 9.8 meters per second squared acceleration that is acting on the motion constantly. Another important thing for you to note is that with projectile motion, the vertical component and the horizontal component are independent of each other. In this particular equation, we can solve for time even though we don't know the x range. We can solve for time using the y component. So let us fix this equation up a little bit to make it suit what we have been given in the question. So S is displacement, and displacement is final position minus initial position. The final position of the boy is 0 meters, but the initial position that he started off was 2.2 meters above the ground. So 0 meters minus 2.2 meters, which is just going to be negative 2.2 meters. So negative 2.2 meters is equivalent to ut plus half at squared. Now u is going to be the vertical component of the initial velocity. We work that out to be 0.547. So we're going to get 0.547 meters per second. And then time, we don't know what time is, so we're just going to write time. Now we come to the acceleration. Now, like I said, I designate down as negative in the coordinate system. So the acceleration of 9.8 meters per second squared is going to be negative 9.8 meters per second squared. And if we have that, we can change a plus to a minus sign. So we get minus half 9.8 meters per second squared. And then we have t squared, which we don't know. So this is the equation that we have. Now we're going to rearrange this equation such that it fits the format of a quadratic equation. In order to do that, we're just going to add 2.2 meters to this side to get rid of the 2.2 meters here and leave us with 0. And then if we add 2.2 meters to this side, we also have to add it over here. So now we're going to get 0 is equal to 0.547 meters per second times time minus half 9.8 meters per second squared plus 2.2 meters. Now we want to put this term up front, so all we do is we put it up front. So negative half 9.8. And at this point, instead of writing negative half 9.8, we could just do the multiplication. So we're going to get negative 4.9. Since half times 9.8 is 4.9. So we're going to get negative 4.9 meters per second squared times t squared plus 0.547 meters per second plus 2.2 meters. So as you can see, this equation is now in the form of a quadratic equation. A quadratic equation has x squared, could be plus or minus, but in this case it's just going to be plus x. And then here we have c is equivalent to 0. So as you can see, this is in the form of a quadratic equation. You can write a, b, and c. So x squared is times squared, which means the 4.9 meters per second squared is a. Here, x is t, (0.547 meters per second is b, and then c is just 2.2 meters. So now that we have the equation in the quadratic form and we have the variables, we can solve for x. So from the quadratic formula, x is equivalent to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So all that's left to do is plug in the variables for the quadratic formula and solve for time. So we're going to get time is equivalent to negative 0.547 plus or minus square root of negative 0.547 squared minus 4 times minus 4.9 times 2.2 all divided by 2 times negative 4.9. And you're basically solving this, right? So when you've solved this, you should end up with an answer of t is equal to, well, when you solve this, you'll end up with two answers. One of them will be negative, one of them will be positive, and that is as a result of these two signs here. Can be plus or minus. We will use the time that is positive since we're looking for a positive time, a time that is greater than 0. So the time that you get that is going to be positive should be 0.728. And we have to put the units, seconds. I could put the units up here, but I didn't write the units for each of these because I wanted them to fit in the screen. But if you wanted to, you could write the units here while you're working it out. It's more work, but it helps you be a little bit more consistent. But at the end, definitely make sure that you have your units. So this is the time that the boy takes to reach the ground from his initial jump. So the third part of the question says, how far horizontally from the truck does the boy land? Now, in order to find that out, we can use another kinematics equation, and that will be S is equivalent to average velocity times time. Now, when they want to find how far from the truck the boy lands, they're actually looking for the distance between where he started, which is here, to where he lands, which is here. So they're looking for this distance. And this distance can be called the range. It is going to be the x distance, or the distance traveled in the horizontal plane. So S is going to be that distance. Now, V bar is average velocity in the horizontal plane. Now, in projectile motion, there is no acceleration in the horizontal direction, which means the final and initial velocities are the same. So the average velocity is the same as the final velocity, which is also the same as the initial velocity. So the initial x velocity here of 1.5 meters per second is the velocity that we will use here. And then time is the time that we just worked out, the time of the entire action. So all we have to do is say that the horizontal distance is equivalent to 1.5 meters per second multiplied by the time, which is 0.728 seconds. And then we should end up with an answer of 1.092 meters. And that is the question completely answered from I to triple I. And that, working out all of that, would give you 8 marks on the exam. And remember to include your units, especially in the final answers. You can include your units while you're working out, but if you do not have a lot of space or a lot of time, then you can omit them so long as you know what your final units should end up being. But units help you to stay a little bit more consistent. So if you have the time and the space, then you might want to include the units while you're working out the question. So now we've given you a little bit of practice. That's going to be the end of the video. So thank y'all for watching. Remember to stay safe out there. Show respect where it is due. And I hope you have a productive day.